Okay, this is a interesting integration question from June 2019, Edexcel Pure 1 paper. You get this diagram, two shaded regions, R1 and R2 here, and it gives you the equation of the curve y equals x, x plus 2 and x minus 4. Part A is quite a nice bit. They're just asking you to show that the exact area of R1 is 20 over 3. So, we're obviously going to be integrating. We need to realise that we're going to have to integrate between these 2 points here. Because they've given it in such a lovely form, this cubic here, but they've factorised it already for us, it's nice and easy. We can see where the roots are. So obviously where these 3 roots are here are where y is equal to 0. And if y is equal to 0, we're obviously going to get values of x equals 0, x equals minus 2, and x equals 4. So minus 2, 0, and 4. So that must be these 3 points here. Obviously 0, we've realised that straight away. The minus 2 here, and obviously that's going to be 4. So to verify R1, we're just going to have to integrate between 0 and minus 2. Not too difficult. So between 0 and minus 2, let's multiply that out so that it makes it much easier for us to integrate. So if we multiply this out, we're going to get what? X squared minus 2x minus 8 times the x is going to give us x cubed. What did I say then? Minus 2x. So minus 2x squared minus 8x. There we go. So that should be quite straightforward. Away we go, we plug it all in, we've got a quarter x to the 4, we get minus 2/3 x cubed, and we get 4x squared. And we just substitute 0 and minus 2 in. So make sure we put the 0 in, lucky putting the 0 in, get nothing. Then put the minus 2 in, and let's see what are we going to get there. We're going to get 4 minus 16 over 3, and we're going to get minus 16 there, aren't we? So plug it all in and we get 20 over 3. So we get our answer. Okay, but you need to show the steps. You need to show that you're substituting incorrectly to get your marks. Right, that's part A. Nice, simple, 4 marks for that, my word. So I suppose you've got several little bits there that you're going to get your marks for, get correct integration, substituting in, but just show the steps. So we get 20 over 3. Right, now it starts to get a bit more interesting. So it then says, for part B, that R2 is the region between 0 and B, so this is our x value of B here, such that the area of R2 is equal to the area of R1. So we need to firstly verify that B satisfies this equation that they give us in the question, just forwarding that down. So we're going to try and satisfy, we get B plus 2 squared. So this is what we're trying to end up with. B plus 2 squared, 3B squared, minus 20b plus 20 equals 0. So that's what we're going to try and verify. So if these 2 areas are the same, that means when we integrate between b and 0, we should also get the 20 over 3 that we got in part A for R1. However, R2 is below the x-axis, so we should get a negative value for that. So when we integrate between b and 0, okay, our integral, we should actually get minus 20 over 3. So what we are going to do is we're going to integrate between b and 0, that's a funny looking b, of this. So what was that again? It's like x cubed minus 2x squared, and then minus 8x. and we know that's got to equal minus 20 over 3. Now, we've already done the integrating for this, so going down on one knee now. So we know that this is, so you've done this in part A, so don't, make any, give yourself any extra work. Actually look at what you've got in part A. And when we put our b in there, and our 0 in there, we are just simply going to get a quarter b to the 4 minus 2/3 b cubed minus 4b squared. Subtract 0 when you put 0 in there. Get me fine with that. Equals minus 20 over 3. Okay? So we need to now get to this form here. So, first thing to note, we've got minus 20 over 3 of there, so let's take this over the other side, because it looks like we're going to have to get it equal to 0, so look for clues always in what you're trying to verify here, or what you're trying to prove. So take the 20 over 3 over the other side, so we've got quarter b of 4 minus 2/3 b cubed minus 4b squared plus 20 over 3 equals 0. Now then, having a little look, we've got some factorising to do here, so it looks like we're going to have to do some factorising. Also, no sign of any fractions, so it might be worth just getting rid of these fractions by either multiplying by, so if I multiply through by 3, for example, and then multiply through by 4, that might be give us some nice numbers, better numbers to deal with. So basically multiply through by 12, because if you multiply through by 4 and multiply through by 3, that's equivalent to multiplying through by 12. And then we're dealing with some nice numbers, we're getting rid of all these fractions. So if I multiply by 12, that's going to give me 3b to the 4, and you can see here, there's a 3b squared and a b that's being squared. So we're expecting to have a 3 here. So multiply by 12 does seem to help us reaching this particular verification here. So times the 3 by 12 here, we're going to get minus 8b cubed. We're going to get minus 48b squared. And then times the 3 there, we're going to get 80. Now this is verifying. So we don't have to, we can see what it's going to be looking like. So we just have to show that, yes, this does factorise down to that. So we might want to do this in 2 stages to convince the examiner that we know what we're doing here. We're going to have to take out b plus 2 squared. Now, we could just multiply this out and then multiply the 2 together and show that, yes, we do indeed get this particular answer. Or we could just do some basic factorising. We realise b plus 2 must go into it. Now, this is where I particularly like to do the spot method. So I just do b plus 2, and I know that multiplies. B plus 2 times that must give me that. So b times 3b cubed will give me my 3b to the 4. Okay, and then 2 times 40 will give me my 80 on the end here. And now it's just a case of, right, what must be my middle terms here? So we've got to kind of work out, right, how do I arrive at minus 8b cubed? How do I arrive at minus 48b squared? Well, the minus 8b cubed, that will come from 2 times 3b cubed. So that gives us 6b cubed so far. Okay. And it will come from b times the b squared term. Now, if I've got to make minus 8b cubed, doesn't that mean that I've got 6b cubed at the moment? I need to make minus 14b cubed? And that's going to be b times minus 14b squared. That's quite nasty, but there you go. That gives us our next term. And then finally, for the b term here, again, let's see how we're going to make these. To get the minus 48b squared, that's going to come from 2 times minus 14b squared. So that gives us minus 28b squared. So far I've got minus 28b squared. I've got to make minus 48b squared, so I'm going to have to make another minus 20b squared. And how do I make minus 20b squared? By doing by doing b times minus 20b. Boom. So I factorised it. Now then, for the next step, you can kind of cheat again. You can go, right, well I know I've got to get another b plus 2, because I've got b plus 2 squared out of this. So I'm going to go b plus 2 times something else equals 0. Now then, I know what it's going to be. It's going to be this, but just to show. B times what makes 3b cubed? Well, that's 3b squared. That's lovely. 2 times what gives me 40? Well, 2 times 20. So all I need now is the middle term here. So I'm going to have b plus 2 times what will give me these two middle terms. So making the minus 14b squared. At the moment, I've got 2 times 3b squared, so that's 6b squared. So it looks like I'm going to have to do another minus 20b squared to make my minus 14b squared altogether. Well, how do I make minus 20b squared? I by b times minus 20b. Oops, got my plus there. So I've done it. And therefore, that is equal to that. Now, sometimes they're a bit pernickety in a verifier show that, and they want exactly the same. So your last line should be writing that out completely again at the bottom, which I'm not bothered doing yet. Okay, and so we verified it. Okay, you don't have to do the spot method. You can do long division, b plus 2 into there. You can multiply these out and verify that yes, it comes out to, that multiplied out comes out to your quartic here. Anyway, there we go. Now then, part C. So, it says the root of the equation, so we've got 3b squared minus 20b plus 20 equals 0. That was part of our thing. Don't forget we have b plus 2 squared here equals 0. The roots of those equations are 1.225 and 5.442 to 3 decimal places. We need to, with the aid of a diagram, explain the significance of this root. Okay? Now, let's see what we're going on here. So firstly, realise that by solving this, we're going to find possible values for b. Now, if you remember, we started off with a b plus 2 here. We had b plus 2 squared. Then we had this. That's what we had to verify in part B. Now, you could look at that and just go, well, hang on, isn't b equal minus 2 one of our answers? Well, yeah, b equals minus 2 could be one of our answers, but doesn't that, we already know that's that root there that between 0 and minus 2 does give us 20 over 3. So of course b equals minus 2 is one of our answers, it's right there. Our other answers for our roots are going to come from these solving this. And they said, right, from solving this, we get these two values. Now I'm looking at that 1.225 is that value there. Okay, 1.225 is that value there. The value of b, so that that area is equal to that area. That's what we're solving this for, is to find what values of b do we end up getting that area equals that area. So it's this 5.442 that is the thing they're trying to explain. And what it is this. If I draw out the diagram again, so we've got our loop here, and it comes all the way down here and then goes up like this. Okay, we know there's R1. And we know when it's 1.225 there, we get R2 in there, and those two areas are the same. Is this 5.442? That's the interesting thing. Now looking at it, we've got minus 2 here, we've got 0 here, we've got this 1.225 here. We know that's at 4, because that's where it cuts through the axis from the original equation. So 5.442 is over here somewhere. Now, what that signifies is this. We're interested in when that is equal to that. So basically, where these two areas cancel each other out to give you 0. So this 5.442 is where the area under the curve here and here is cancelled out by the area under the curve here. So what we're looking at is the other values where the areas under the curves are cancelled out by the areas over the curve. So it's the value of x such that the areas bound by the x-axis, the curve, above the x-axis are cancelled out by the areas bound by the curve and the x-axis below. So it's where that area there and that area there added together is equal to that area there. That's the significance of this 5.442. That's why we're getting another value that doesn't seem to make sense, but that's all it's just equating to. Because this is all about areas balancing each other out. Okay? Quite an interesting little question that on integration.